Orifices are the most popular liquid flow meters in use today. The Orifice Plate is used most extensively due to its simple shape, easy manufacture, and high accuracy, although large pressure loss is inevitable. An orifice is simply a flat piece of metal with a specific sized hole bored in it. Most orifices are of the concentric type, but eccentric, segmental and conical, quadrant, designs are also available. In practice, the orifice plate is installed in the pipe between two flanges. Acting as the primary device, the orifice constricts the flow of liquid to produce a differential pressure across the plate. Pressure taps on either side of the plate are used to detect the difference. This orifice is used for measurement of flow of liquids without foreign matters such as precipitation, etc., gases not producing condensations, saturated steam, or superheated vapor. This type of orifices are preferred for multi-phase flows in vertical lines. Eccentric orifice. The eccentric orifice is similar to the concentric except that the opening is offset from the pipe's center line. These are best suited for flow measurement of multi-phase fluids in horizontal. Segmental orifices. The opening of the segmental orifice is a segment of a circle. These orifices are used when fluid contains foreign matters such as precipitation, air bubbles, etc. Advantages. Major advantages of orifices are that they have no moving parts and their cost does not increase significantly with pipe size. It is approved by many standards organizations for the custody transfer of liquids and gases. Disadvantages. Calls for a process shutdown whenever the plate is to be removed for maintenance or inspection. Sensitive to a variety of error-inducing conditions like precision in the bore calculations, the quality of the installation, and the condition of the plate itself determine total performance. Installation factors include tap location and condition, condition of the process pipe, adequacy of straight pipe runs, gasket interference, misalignment of pipe and orifice bores, and lead line design. Other adverse conditions include the dulling of the sharp edge or nicks caused by corrosion or erosion, warpage of the plate due to water, hammer and dirt and grease, or secondary phase deposits on either orifice surface.